So today we're beginning chapter 9, which is congruence and similarity. The first section is on congruent and similar figures. Today we're just talking about congruent figures. Okay? And what does congruent mean? If I have two figures and they're congruent, it means, Liam, they're equal. So they have the same, what? Hannah? Size and shape. And we're going to write that down in a moment. Same size and shape. Actually, since you said that, maybe we should do it right now. Same size and shape. Okay, so today is about congruency. And so here we have two figures. You need to draw them. And I'm telling you that they're congruent. Okay, so we can write a sentence of congruency, and it looks like this. It's not complete yet. We need to complete this sentence, but we have triangle LMK is congruent to. So there's that symbol of congruency, an equal sign with a wavy line on top. Triangle blank. We're going to have to fill that blank in. How are these triangles congruent? Triangle LMK could have been written other ways. We know that we need to list the vertices in consecutive order, but triangles you can name a lot of different ways. But because it was named this way, we have a particular way we must name the second triangle. And who knows what the first vertex of the second triangle has to be? Wesley. He says Q. Thumbs up if you agree. Good. And why is it Q? Wesley? Good, so he says if you orientate the triangles in the same way, they'd be in the same spot, Q and L. That's true. And they have the same number of degrees. They look about the same kind of angle, don't they? And where would we go next? What is congruent to the second letter here, M? What do you think? Rachel?
R.
And very good, R. And they look to be what kind of angles?
Right.
They look like right angles, but we don't know that for a fact, but we do know that they are in the same position on those triangles. And so everybody, the last letter would be? P. Okay, so this is a congruency statement. And what we want to do when we receive congruent triangles or congruent quadrilaterals or whatever the polygon, we want to write this sentence. And then we want to rely on this sentence to answer a bunch of questions. Okay, so I could even throw out the picture and just rely on the sentence. And one thing we might be able to say, based on the sentence is, which angle is congruent to angle L? So we look here and we say angle L goes with which letter in this triangle QRP?
Q.
Q. They come together, so we say angle Q. And which angle is congruent to angle M? Good, angle R. And which angle is congruent to angle K? Good, P. I hope you're all following. We can do the same with the sides. Because they're congruent triangles, I can look at side LM, segment LM, and here's LM. I'm not even going to bother looking at the picture. I'm just looking at the sentence. LM is congruent to what segment? Good job, QR. So sometimes the figures are flipped and rotated and reflected and all this kind of stuff. And when you have this statement, you can clearly find the congruent sides and angles without even looking at the picture anymore, which is really nice. How about MK? What is congruent to MK? Courtney?
PR.
MK with PR, good. Could you also say RP? You actually can, because it's just a length, but it's nice when you phrase it that way because it looks exactly like the same order we saw over here, right? And then the last one says KL. So what is congruent to KL, everyone? And you might say PQ or QP, right? Very good. So we are saying that when you have corresponding figures, that when you have this sentence, we can actually say that we need to list the corresponding vertices in the same order. And we have all of these relationships we can find when we do that. Okay, so let's use what we know about congruent polygons. You might receive a picture, and if you're really lucky, you might receive even the sentence too. So in other words, here's the congruency statement, and then here you have a picture of both triangles. So the question is, find the measurement of angle D. So you might need to pause and draw these things, right? Okay, so if we're asked to find angle D, we take a look at all the information provided and see if we can find it. There's more than one way to look at this, but we do know that these two triangles are what? Congruent, so we know a lot. If we're considering angle D, what is angle D? Angle D, which angle is angle D congruent to? And angle A. We're just able to see that right here in the congruency statement, which is the best place to find it. Because sometimes when you have a triangle that's got one angle A upright and angle D is the corresponding angle, but it's upside down, it makes things very confusing, right? So let's look and see. When I look at this triangle, the second triangle, EFD, I don't see a lot of information. The only piece of information that gives me an angle is right here. So what's the number of degrees in that angle, everyone? 90. Okay, so that's all I know. And I don't know F and I don't know D. That's a lot of unknown, right? But let's go look at this triangle over here. Triangle ABC, we know this angle is what? 90. And we know this angle is what? 35. So do we have enough information to find the unknown angle there? We do, because how many degrees are in a triangle? We got to remember that, 180. So who can tell us how to find angle A? Measurement of angle A would equal what? Lauren? And take away 35. So she says the entire triangle is 180. Now take away the two angles you know. Right? Take away 90 for this angle, take away 35, and then we'll know what remains, and that's angle A. So what is 180? Well, 180 take away 90 is 90, right? And 90 take away 35 is 55 degrees. Very good. So the measurement of angle A is 55 degrees. So can we answer this question here? Find measure of angle D? And it is 55 degrees. The measurement of angle D equals 55 degrees. Okay? So again, geometry is like a chain link. We find that D is congruent to A, and I can figure out A over here and then bring the information back to the triangle where the question is, angle D. Okay? Geometry, one of the best strategies is to draw the figure and fill in the known information. Another strategy might have been that we knew angle C was 35, and which angle is congruent to angle C? Look up here. Angle C is congruent to F. So we could have come over here and filled in 35 degrees. Away commercials. You know what? Why does it do that? That's great. 35 degrees. So we could have found the angle D by filling in the known angles actually over here. Another way to do it. Okay? Sometimes we don't have a picture, so we're going to do what we did on the very first, the very first page. Even without a picture, you know a lot when you're given a congruency statement. So if triangle ABC is congruent to triangle POD, then let's answer these questions and come back and see if your answers are correct. Okay, how about angle A? Sterling, what's angle A congruent to?
Angle P.
Very good. So A and P. We don't even have to have a picture. How about angle C? Bianca?
It's angle D.
Good. Angle D. And segment AB. Charlie? Segment PO. And how about segment DP, Nicholas? Segment CA. Very good. Okay, so we love the congruency statements. Very good. Okay, there's a little section in today's assignment where they expect you to read and learn while you're in the assignment, but I'm going to give you a little preview right now. There are 3 tests for triangle congruency. If you want to know whether 2 triangles are clones, congruent, same size, same shape, then you may use these 3 tests, which are described in your textbook. But we're going to put them down here as a little preview. The first test is called side, 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 which basically says if I have 2 triangles and they both have 3 equivalent sides, guess what we can say about these 2 triangles? They are congruent. Right, they're congruent. So go ahead and make a triangle out of your 3. We're doing this with pencils here. Let me see if I can start. And I have Ryan here helping to demonstrate. So we have 2 triangles made from 6 segments, all of the same length. They're brand new pencils, okay? So when we form a triangle, is there any way to form a triangle that looks different than this with these? Is there any way? I mean, if it was a quadrilateral, we might be able to slant it, and do different things, but with triangles, no. Once you have 3 sides that are the same, you have congruent triangles. Okay, so that's our first one, side, side, side. So let's put a little definition and a description. Okay, here. Who wants to come up and be in the video? Okay, so the second test is SAS. Nicholas, come on up. I hope that you're... Do I have the video going? I think I do. Come and stand right here where Ryan was. So SAS, what do you think that stands for? If SSS is side, 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 SAS is side, angle, side. So that basically says that if I take two sides that are the same, side and side the same, right? Side and side the same. And if we make the angle exactly the same between them, so does that look the same? Where are you going? Does that look the same, angle-wise?
Yes.
Okay, so when we make, now pull it away, don't move the angle though. Keep the angle the same. Now when we make the third side, there's only one way to make it. There's only one possible third side that will work. So side, angle, if you have a side, an angle, and a side that are congruent, you have congruent triangles. Thank you, Nicholas. Okay? And so you might want to pause and take that down. Side, angle, side congruency. It's really important that you know that it's 2 sides and the angle between them, right? And it's not 2 sides and an angle somewhere else, like SSA or ASS. We would never have that here. It is always like a sandwich, SAS, right? Either SSS or SAS, a sandwich, okay? The other kind of sandwich we could have is what? Give me the other sandwich it's possible here, Hannah. ASA. Good. And so that's our third test for congruency, ASA. Okay, so angle, side, angle. We now have Braden here to help demonstrate. We now have the second type of sandwich, the ASA. So what this is saying is if I have an angle, let's make one a right angle.
Come on, Braden.
And a side. Let's make it the red side. Can you put your red side down? Red side down. Angle. Okay, we have matching, right? And if I have a third angle, or I'm sorry, a second angle, so here's the side, and between them we have 2 angles. You make it go over and touch the other side?
It's a triangle.
There's only one way to do this. And so we have now congruent triangles. Do they look congruent?
Yes.
Yes, they are. Even if I flip this over here like this, it's still congruent. Okay. So our third test for congruency, thank you,
Good job, Braden.
is angle, side, angle.
You're a pro.
So let's try this question here. How do you know that these triangles are congruent? So think about the tests we just talked about. We had the 2 sandwiches, SAS and ASA, and then we had the SSS. So which of those tests would prove that these 2 triangles are congruent? And who has it? Thumbs up if you have it. 3, 2, 1.